Hi, I'm Derek Robinson, a senior technical online course developer here at InterSystems. And in this video, we're going to go over a use case for implementing Health Connect or InterSystems Iris for Health, and the way that you can construct a sort of testing harness with two different namespaces to be able to test out the integration that you're building for a client or a customer. So going into this video, we're going to assume that you have some of the knowledge around interoperability productions, inbound hosts and outbound hosts, process hosts in the middle, including routing rules and data transformations, and all of the interoperability concepts that are core to InterSystems technology. In this example, we're going to be building a system for a client, and so we'll call that client up here. And the base use case that they're doing is that they want to take HL7 2.3 messages on the way in. They'd like to transform them, and on the way out, they'd like them to be HL7 2.5.1 messages. Now, the way that they're receiving these messages is that they have an inbound host that looks on port 5000. So this is the basic spec of their use case. They'd like you to build an integration for them that does this, essentially. Now, this part of it in the middle is simple enough to be able to build an integration that does what they're looking for, but without going into the live system, it can be difficult to simulate what you actually get on the inbound and outbound sides of this potential application. And so by creating a second namespace where we can simulate the upstream and downstream systems, we can better grasp what might happen on the front and back end of this transformation that we're looking at. So by using two different namespaces, we can more effectively simulate the situation that we're going to have when implementing this actual integration for a client or a customer. So on the top here, we have a namespace called transform data. This is where the production will run that is the actual integration that you might build for a client or a customer. And on the bottom here, we have another namespace called test namespace, where in the same production, we'll actually simulate both the upstream and the downstream systems. Now, the advantage of this approach is that you don't need to, go metal into a live system to be able to make these integration updates. Instead, you can build this kind of testing harness where you can create an upstream and downstream system that replicates what your client's going to actually have on the upstream and downstream ends of their use case. So following the sample journey of this HL7 2.3 message being transformed to HL7 2.5.1, let's start there in the upstream system on the test namespace. So first we have an inbound host that's called local HL7. Now the local HL7 inbound host is a file host, and with any file host, it is pointed at a file location. In this case, the in folder that we have here is the location where local HL7 will look, and it's waiting for a message to be dropped into that folder, and it'll scoop it up and begin processing it according to the production. From local HL7, we go to the other side of the production where we have an outbound host called to system 1. So to system 1 is going to be sending us up to the top system here, which is where our actual client integration is being built. Now you can notice on the side of the diagram there, we have S1, S2, and S3. Those are simulating the system 1, which is the primary integration, system 2 being the upstream system, and system 3 being the downstream system. So that outbound host is to system 1, and what that's going to do is it's going to send the HL7 message, still version 2.3 at this point, to port 5000, which is where, up in our actual client integration, the inbound host is looking for that message on port 5000. So the host that we have here is going to be called HL7 in. And this host job is really to monitor port 5000 and wait for a message to arrive. Now, once HL7 in receives that message on port 5000, we get to the part that is really the guts of this transformation, which is actually transforming that HL7 2.3 message into HL7 2.5.1. So all of that is going to be done in the process host. So the process host that we have here is going to be called HL7DT. Now, a process host itself usually contains multiple different types of elements, such as data transformations, routing rules, things like that. And so in this case, we have both of them in the actual demo that you'll see, but what we're focusing on in the conceptual overview of this is the data transformation, and it's called transform1. Now, of course, in real use cases, you'd have a more applicable or relevant name than this, but transform1 in this case is going to do the basic thing that our integration is trying to do, which is transform an HL7 2.3 message into HL7 2.5.1. So that's what transform1 does, and then the process host, HL7DT, with that transformed message, is going to send it to the outbound host on this production, which is InterSystems 3. So InterSystems 3 takes this transformed message, and now it's going to send it out to wherever the client's integration is going to be sending out. In our case, we're going to use our simulated downstream system to be able to do that. So InterSystems 3, unlike the host on the other side of the production, is a TCP host, which means that it's not going to be doing file moving of the message. It's going to be doing it via TCP. And so in this case, InterSystems 3 is going to send actually to port 5001. In our use case, we're doing both of these on the same machine, but wherever the networking location is that the downstream target is, that's where InterSystems 3 would send its message. For our testing harness, it's going to go to port 5001. And on port 5001, we have this inbound host called from client that is monitoring 5001 for a new message. Now, as you can see, we've moved to the bottom row, and this is now our downstream system that we're simulating in this production with the inbound host that is looking on port 5001. So from there, it scoops that message up, and it's going to send it out to the final host in our entire workflow here, which is toLocal. And toLocal is a file outbound host, which is connected to a location here, the out folder that you can see, and that's where it will output the final message. So to kind of recap the workflow here, if we start by the input folder getting an HL7 2.3 message in, it's going to be consumed by local HL7. It's going to be sent to InterSystems 1. InterSystems 1 will send that message to port 5000, where HL7 in is an inbound host waiting to scoop it up. HL7 in will send it to the HL7 DT process, and there it will do its transformation, making this now, at this point, a 2.5.1 message. So up until that point, it's been an HL7 2.3 message. Now it becomes an HL7 2.5.1 message. That message is sent to InterSystems 3, which in turn will send all the way over to port 5001, which is the start of our downstream system. And that downstream system will begin with from client, sending it to toLocal, and toLocal putting it into this output folder as a 2.5.1 HL7 message. So let's take a look in the management portal and see what this actually looks like in practice.
All right, so now that you've kind of seen the conceptual workflow of this sample integration, let's take a look at what this might look like in the management portal. So as we head over here, you can see that we have two different namespaces as discussed in the diagram. We have test namespace and transform data. So with test namespace, that's going to be simulating both the upstream and the downstream systems. And transform data is where you're going to simulate the client's integration that they would actually be using that you would set up for a real customer transformation, taking HL7 2.3 and going to HL7 2.5.1. So following the flow of that sample message, let's take a look at test namespace first. So if we navigate to the production screen in the test production, and we can look at here, we have 4 different hosts within this production. We have on the bottom, local HL7 and InterSystems 1, and on the top, we have from client and toLocal. The bottom two here are going to simulate the upstream system, so we'll start there. With local HL7, this is a file inbound service. So what this is going to do is it's going to look at a file location, which is defined here in the file path setting. And here you can see that it's pointing to the HL7 in folder. Now on my machine, I do have this HL7 in folder, so that's where the local HL7 inbound host is going to look to scoop up new files that are added there to process through the production. On the other side of the production, we have this outbound host, which is InterSystems 1. And this one is not a file host, this is actually a TCP host. And so in this case, since this entire demo is running on the same machine, we define the IP address as 127.0.0.1 and the port as 5000. So what we're going to see here is that from local HL7, going back to this host, there is a few settings here that are defined, and one of them is target config names, which defines where the messages will be sent when they come into this inbound host. In this case, we have InterSystems 1 as the recipient, so you can see here the line connecting these two hosts, and we have message schema 2.3 because the incoming message is an HL7 2.3 message. So that's the route that it takes on the upstream system that's simulated here. And now we can hop over to the other production to see in the transform namespace what this looks like once that message is sent to port 5000 from InterSystems 1. All right, so if we switch over to the transform data namespace, we have here the first inbound host is HL7 in. So as you might imagine, as you look at this host, it's a TCP inbound host and it's looking on port 5000, which is where ToSystem1 sent that message to. You can see that here the message schema category is 2.3 because we still have not changed the format of this HL7 message, haven't done any transformations or anything. But the target config name here is HL7DT. And as you can see in the diagram, that's a process host sitting in the middle of our production. So within this process host, we have both a rule and a data transformation. And we're going to take a look at this right now. And we'll start by looking at the data transformation. So to do that, we're going to actually navigate in the transform data namespace to look at the transformation from the list view of the data transformations. So if we open up this demo.transform1, we'll see here the data transformation editor. Now this transformation has a lot going on the screen, but we'll kind of walk through each of the key pieces. First, on the source message here, we have a 2.3 ADT A01 message. That's the incoming HL7 message that we got from our upstream system. And then on the outbound side of this, we have a 2.5.1 ADT A01 message. So the same type of message, but going from schema 2.3 to 2.5.1. As you look at the source and target message here in this transformation, you can see that many of these fields and segments are being mapped directly. So for example, we have the MSH segment is directly mapped to the MSH segment on the target. So a lot of these are just directly taking the segment from the source and applying that in the target message. But if we look at the actions down in the bottom of this screen, we can actually scroll down to see a few areas where we're doing something a little different. So within that MSH segment, for example, if we expand each of those, we can see that if we scroll down to the MSH12 field, which is version ID, we're actually setting that directly to 2.5.1. As we said, the outbound message is going to be of format 2.5.1. And so here we're manipulating the data in this segment to have the version ID say 2.5.1. If I collapse that one and scroll a little bit further down to this next example, which is in patient name, we have the PID segment. And within PID, we have patient name being mapped, but you can see here that we're actually applying a function in this transformation. So this toUpper function is going to uppercase that patient name. So that's just kind of an arbitrary example here, but we'll see what that looks like when we test out the transformation. And then lastly, we have this EVN segment, which if I reset the PID collapsible here, if we go to EVN, and we look at what is available within this segment, we have EVN7 is a field that in the target message is there, but as you can see in the source message, which is of type 2.3, the EVN7 field is not there. There is no event facility field here. So in this case, to set the event facility field, we're just going to set this to a string that says unknown. This way, you might want to account for something that you know won't exist in your target message, and you're going to set a string directly to say that that is unknown. So apart from all these straight up one-to-one mappings, we've got these three different transformation activities that we're doing with set actions on these three different fields. Now let's take a look and see what this looks like when we test the message out. All right, so up in the top right corner, we have this testing button, and we can use that to test out a message. So I'm going to grab the sample message that I have here, and we're going to copy this sample HL7 2.3 message and paste this in. So when I click test here, we'll take a look at both the input and what the output message is. So I'll call your attention to mainly the three things that we pointed out with those bottom three set actions. So first, in the very first segment, the MSH segment, we have this version ID of 2.3. And when we look at the output, we can see hovering over this 12th field in the segment here, we have 2.5.1 is the new version ID. So that transformation was successful. Just going sequentially in the message, this was the third thing that we showed, but we have this EVN segment where in the source message, you can see on the EVN segment, there's nothing after this long ID number that you have here. And in the target message, you can see that the string unknown has been added on that 7th field for the event facility. And lastly, we can look at the patient ID segment and that PID segment there. And you can see that there's a couple of names here. We have John Doe and we have Jane Doe. And matching that field, which is the given name that we had mapped to, the Jane Doe name, you can see is now uppercased, where the John Doe name is still lowercased. So again, that one's an arbitrary transformation, but up here we have Jane Doe in lowercase, and down here in the target message, we have it in uppercase. Just a simple example of how you can apply a function to some of these values to transform them for your target message. All right, so having tested that message, now let's take a look back in the production screen to look at how this is actually implemented in the HL7 DT process host. So within this host, you have a routing rule and a transformation. Now the transformation itself is just defining how this message transforms. It doesn't take the action itself. What really you need to implement this transformation is a routing rule, and so that's what we have here. We have this demo.hl7dt routing rule. And so this is a really simple rule, but when we look at the conditions here, we have basically if true by saying if condition is 1, then the actions we take are to send to system 3 with the transformation of demo.transform1. So what that's going to do is take this message in, apply that demo.transform1 transformation to it, and then send it off to system 3. So that's the core logic of the integration that's happening right in this process host. And if we continue on to the rest of the process, we look at the system 3 outbound host. And as you might expect, this is a TCP host. And we're going to send this one to the same IP address because we're on the same machine, but this one's going to port 5001. So whereas the message came in on port 5000, we're going to send the outgoing message to port 5001. So to see what happens on the other end of that, we'll head back over to the test namespace. So in the test namespace, if we open up this production again, now we'll shift our focus to the top 2 hosts on the production screen. We've got from client and we've got to local. So this is now simulating your downstream system. These bottom 2 hosts simulated the whatever is upstream that created that HL7 2.3 message. And now these top 2 hosts from client and to local are simulating whatever is downstream, receiving the HL7 2.5.1 message that you transformed. So if we look at from client and take a look at the type of this host, we see that it is a TCP host that is looking on port 5001, which is where that 2.5.1 message was sent. So it's looking on port 5001, and it's got its target config name set as toLocal. So this toLocal outbound host is where the message will be sent when it scoops it up from port 5001. Note here that the message schema category now has changed to 2.5.1. So it's looking for that, and this will validate that a message that comes in should match that schema. If it doesn't match that schema, it may not pass validation. Lastly, we go over to the outbound host, the toLocal, and just like we started the demo with, this is an outbound file host. So we started with an inbound file host. This is an outbound file host. And if we look at the file path here, because all file hosts will have a file path defined, you've got HL7 out as the folder that is defined here. This is where messages are going to be outputted to when they come through this outbound host. They'll be outputted after their transformation to this folder. We've also got this file name here where we can set the format of the file name that is outputted. And so here we're just saying output message, and then we're appending after that, I think it's a timestamp that is the %q variable there is appending a timestamp to output message. So that's what we've got for the workflow of this. Now what we can do is we can head over and see how this works when I drop a message into that input folder that HL7in is looking for. So if I take this sample message and I copy it, and now what I'll do is I'll go to the HL7in folder and I'll paste it here. And this message should disappear pretty quickly because our production is running. And as you can see, it just ingested that message. And sneak peek, you can see that it's been put into the HL7 out folder. But let's take a look back in the test namespace to look at what actually is happening with that message coming in. So if we look at the message viewer, and I'll refresh the page here to get the latest from the messages, you can see here that there are a few messages that came in most recently, and we can see the source is local HL7, the target is system1. And so this is the message that we're looking at on this particular production that we want to take a little closer look at. So as I click this message, you can see that you can inspect its trace. So right here, we can see the inbound host, local HL7, and we can see that this HL7 message was sent to system1. If I look at the details here, you can see some of the stuff that you would expect from the earlier conversation. If you look at the body of this message, we can see the doc type is 2.3 ADT-A01. So that's exactly what we expected, the incoming message being HL7 2.3. If I switch to the transform namespace now and open up the production here, we can look at the message viewer on this one, and we can see that the message most recently that came through here started with HL7in and was sent to HL7DT. So if we look at this trace, we can see here, just like we might expect, the inbound host HL7in sent this to HL7DT, And then HL7 DT applied this transformation and then eventually sent it to 2 System 3. So looking at the first message here, if I pop open the side panel, we can see in the body of the message that the doc type should still be 2.3 ADTA01 because the message has not yet been transformed. But if we look at this second message, we can see here that the doc type has now changed to 2.5.1 ADTA01. Now, you can also look at the raw contents of the message from this view, but generally it's a little bit easier to pop that open into a new window and look at the full message that way if that's what you're desiring. So from 2 System 3, we know that that message goes outbound. And so for checking that that got received on the downstream end of the simulation, we'll head back one more time to the test namespace and we'll look at this from client. And that's where we know that that message was received back. Going back to the message viewer, we can see here the most recent message in the queue is from client and it goes to 2 local. That's the end of our workflow. And if we look here, the from client inbound host sent this to the outbound host. And as we pop open the side view here to look at the doc type, as we expect, it is 2.5.1 ADTA01. So the last step here is to actually look at that output message that we previewed a little bit when it popped up. And if I open this up in a text file, we can see here I have the 2 messages side by side. And I'll highlight quickly for you that the 2.3 version in the original source message has now been changed to 2.5.1. We've got the Jane Doe lowercase name that is now an uppercase name in the target message. And then finally, that unknown string that was not here in the EVN segment originally has been added to the EVN segment in the target message. So this is kind of a workflow of how this sample setup with 2 different namespaces can simulate your upstream and downstream systems, as well as the kind of core transformation that you're looking to build. And that way you can have the confidence that when you've built this integration, you've tested the possibilities on the upstream and downstream sides of it when transforming your HL7 messages.